It's showtime. Welcome to Chill Skills Sporlan Tech Talks. The topic for this episode is supermarket metering devices, electric expansion valves, or as they're otherwise known as EEVs. This is the seventh, if I recall correctly, in a series of presentations that will follow the agenda of the old supermarket seminars. In the past, Sporlan had a team of professionals on a supermarket team that went around the country to facilitate these presentations in person. With this Tech Talk entry, we're bringing the supermarket seminar concept back and hopefully servicing a bigger audience in the process. Thank you all for joining us today. And just so you know, here's a shameless promotion for the next bunch of webinars that we're getting ready to do. One on May 21st, that's just next week. We will discuss refrigerant retrofits. And then again in June 18th, we will continue the discussion on metering devices with a focus on distributors. Now that's specifically refrigerant flow distributors and not aftermarket wholesalers.
That is correct.
Now, just a few instructions for you. If the speaker on your computer doesn't work, maybe you need a new computer, but you can simply dial in with your phone. There should have been a phone number somewhere on the invitation that you originally received for this webinar, and please mute your microphone. As we move along today, we may have questions. You can type those questions into the Q&A window. If we have time, we're going to answer those questions live, but we've got a pretty good sized group today. We may run out of time to do that live. Now, just so that you know, we're planning to do a Q&A blog for every single question that comes in that we're able to capture, and we'll provide an answer that we eventually post online. And just so that you know, if you're patient, there's a good bet that along the way we'll answer your question during the course of the webinar itself. And we're also recording this, so should you run into any broadcasting problems, you can always go back and listen to the recorded version. It will appear first on Facebook Live and then later on the Sporlan YouTube channel. Hello, I'm that guy on the left. I'm Jim Jansen, Senior Application Engineer for the Sporlan application team. My stunt double today and technical backup is Brad Pitt. I mean Glen Steinkaning. Glen is a product manager in the marketing department, and he also collects a paycheck from Sporlan. He's the smart one of the two of us, and somebody needs to be. Hey, Glen, you need to say hi.
Well, hello, Jim, and hello, everybody, and welcome to the webinar.
Somebody who we didn't introduce that's in the room with us, that's Phyllis back here behind me. That's our communications director. She's here to tell us what to do. Not that we're going to pay any attention to her, but she's going to tell us to advance slides, not to advance slides, to talk, to stop talking and that sort of thing. But if you have any follow-up questions or feedback for us, you can contact us via those email addresses you see below each one of our images, or you can contact Sporlan Tech Support directly at svdtechsupport@parker.com. And we'll flash that email address up at the end. And we've also got people that will actually speak to you on the phone. Area code 636-239-1111 is a number that you can dial to actually get into our tech support team. And that is application engineers that can help you with problems, should you have them and you want to speak to a human. That's kind of a novel thing these days, right, Mike?
It absolutely is, Jim.
Now, it's good to know the four primary components in a vapor compression refrigeration cycle, and here they are. They're comprised of the compressor, which I'm going to go on the premise everybody knows what that does, the condenser, and here I'll even get one of these fancy laser pointers. Here's the condenser, the metering device, which last month we talked about thermostatic expansion valves, and that's what we show here. But today we're going to focus on electric expansion valves, and then next month we're going to talk about refrigerant distributors. And then finally, the fourth primary component in this cycle is the evaporator. Here is the whole duplex, multi-rack, very complicated system. And if you try to digest the whole thing, it can be quite overwhelming. So that's why we're taking it in chunks. And we're looking at this part of the system today. Specifically, we're looking at the highlighted device that you see there. In this case, the EEV. The EEV controls refrigerant flow to the evaporator based on superheat. And we're going to try to ultimately keep a handle on that. We'll be discussing the use of the EEV package to control that parameter today. And during future webinars, we will discuss the use of step motor valves and associated controls to handle other duties within a supermarket refrigeration system. Now, Sporlan manufactures a wide variety of electric expansion valves. And they range in capacity from 2.5 up to over 400 tons based on R22 as a baseline. Now, we'll talk a little bit more about that. Some are even equipped with an indicator window similar to the Sporlan See-All. Glenn, why would we do that?
Well, Jim, it's one way of being able to see what's going on with the valve operation. And then it also has a moisture indicator in there. If you actually take a look, there's a ring of yellow.
Like right there?
Yeah, a ring of yellow right inside that window. And that yellow is the moisture indicator, same as in the Sporlan See-All. So it will change to green when the system is dried down by the filter dryer upon operation.
Okay, that's kind of neat. So that's not just crud that we left in the valve when we got done making it. That's actually supposed to be there on purpose.
It's an intentional part, Jim.
Awesome. Now, something that continually comes up, and I actually failed to discuss it on that previous slide. Inevitably, everybody refers to these valves as electronic expansion valves. Whereas back here on this slide, the bulk of those valves are actually electrically actuated. They don't have any control mechanism built into the valve. They're relying on a separate controller to tell them what to do. And so in that situation, they're simply an electric expansion valve. Whereas here, these valves that are depicted in this image actually have a controller as part of the valve package itself. And so these truly are electronic expansion valves. And we continue to make a few of these to this day, but I just thought I would differentiate between the two because I'm kind of funny that way.
Right.
But before we go any further, the question comes up, why consider the electric valve and the necessary controls that go along with it? Well, here are a few reasons. The commissioning process is much simpler. You key in or select the parameters and you're ready to go. The process to set superheat is potentially much more time consuming with the traditional mechanical thermostatic expansion valve. There's no need to unload the case. I mean, it's a pretty straightforward affair. In the event that there's a refrigerant retrofit that's getting done, and how often does that come up, Glenn?
It's coming up more frequently as we go through life, Jim.
So in a retrofit situation, there's generally no need to change components, provided the control accommodates the new refrigerant. TVs are refrigerant sensitive, thermostatic charges, valve capacity. That all has to be taken under consideration when you're selecting a thermostatic expansion valve to control superheat at the bulb. The control range is also significantly wider compared to the mechanical version, with less sensitivity to changes in weather and hence load. Glenn, how does that come into play? What does that mean?
Well, like for example, that first valve we talked about being a 2.5 ton valve, they can actually control all the way down to 10% of the valve's capacity. So roughly 1/4 of a ton. But if you had a standard mechanical thermostatic expansion valve, you could only come down to maybe say 35% of its nominal capacity, meaning it won't control over that wide range. So if you had something like a subcool control that was changing out the temperature of the incoming liquid, that could actually affect the capacity of that valve. This can actually handle it perhaps a little bit better in certain cases where you're close to the edge of that operating envelope.
Okay, so that's where the changes in weather really come into play. And a supermarket, it's got to operate all year round. Now here, this last one, this is a real deal here. Just try monitoring the case operation remotely with a thermostatic expansion valve. Yeah, that's a trick.
Yep.
But you got to be a little careful here. Nothing's perfect. In the case of EEVs and controllers, they are a little more complex. You've got sensors, you've got wires. There's a little more upfront cost, but there's a payback that's associated with that that's a good thing. But I can't go further without putting one last plug in for mechanical expansion valves, and that is they are wireless.
That they are, Jim.
Here's a cutaway of a typical motor assembly. It shows the cable coming in, the 4-pin connector, the motor housing, the stepper motor itself, the gear drive, the gear shaft, down to the lead screw. Part of this assembly is often referred to as a digital linear actuator, and we go over to our manufacturing plant, they talk about DLAs all the time, and I thought that was some kind of position that the major leagues were going to start to use to facilitate the game. That's not what that is.
Nope.
In essence, the DLA converts the signal from the controller and turns it into a linear movement of the pin as it interacts with the port, and ultimately controls superheat in this application. Here, Sporlan EEVs for refrigeration use are typically of what is called a bipolar step motor design. The bipolar motor design has 2 separate motor windings. By applying a 12-volt signal to certain leads, the valve takes 1 step. Additional steps are taken by applying voltage in the following sequence, as you can see in the slide here. Reversing that sequence causes the valve to close versus opening, but we'll talk a little bit more on that really soon. Common Sporlan step motor valves have between 1,596 and 6,386 steps, and with some in between. The intention with this is to provide a great deal of resolution in the control process. So what makes this motor bipolar? Well, I don't want to get too deeply into that, just to say that Sporlan also manufactures unipolar style motors. Includes a number of different steps and torque requirements, and that's typically for specific applications, and believe it or not, we'll talk more about that on another webinar. Now here, we said something about this just on the previous slide. Reversing the sequence causing the valve to close versus open. This chart actually depicts what happens for all the different combinations of lead wire termination, ranging from normal operation to reverse operation to simply no operation. And you can see that's depicted here, right? Glenn?
Absolutely.
Pretty cool. And I really got to put a plug in for our Mr. Pat Bundy, who still works for us, for creating this chart. He sat down one day with a step motor valve and some diagnostic gear and figured this all out some number of years ago. He was one of those supermarket group guys at the time. You know, Glenn, what would be really funny is if we found out that Pat was colorblind.
That would have been funny.
Now here is an animation that's going to start in just a second. It's going to depict the M12 connector with the IP67 protection rating. M12 means this is a 12 millimeter connector, and ours happens to be fitted with 4 pins, as you can see here. IP67 means the unit can be dropped into fresh water about 1 meter deep for 30 minutes and still work, and it's pretty resistant to dust. The style of cable that you see here is actually removable and can be reattached as well, and you saw that in the process. Some of our other cables could be removable, but you're going to have a hard time putting it back together. With this new 4-pin connector, it's almost foolproof during the reconnection process, and it facilitates that. You'll also hear, you briefly saw the inner workings of the valve. Now, all EEVs require some type of controller to drive the valve, to tell it what to do. I mean, when we're talking about true electronic valves, they have got a controller built into the valve structure. Most of the other valves, though, have to have some type of independent device that does that. Suction temperature and pressure as inputs are typically sent to the controller, and the controller calculates the current superheat and adjusts the valve subsequently to create the desired set point. EEV controllers can be categorized as standalone or integrated. Sporlan standalone controller, as you can see here, the superheat control is built on the Kelvin 2 platform. Its sole purpose is to control superheat. It uses a temperature sensor. Where's that temperature sensor? Can you see it on here? There it is right there. It uses a temperature sensor and a pressure transducer to calculate superheat and then positions the EEV accordingly. Upon powering up the controller, the installer is prompted for system information such as, here's a good one, number of EEV steps. Why is that important, Glenn?
Well, because not every valve out there has the same number of steps, and therefore our controller needs to know which one it is and how many steps so it can tell it exactly where to go and when to go.
Well, at least respectfully anyway.
Yes.
Okay. Refrigerant type. Why is refrigerant type important?
Because not all refrigerants have the same pressures at the same temperatures, and therefore it needs to know that in order to calculate superheat properly.
Well, it's also going to want to know what kind of sensors you're using and the range associated with them.
Well, of course, the sensors all come in different ranges and capabilities, so it needs to understand what that is so it can give the right output because it's reading the input correctly.
And then ultimately, I guess you have to decide what the set point parameter is going to be, such as the superheat set point, and you got to select that. Now, if this was a thermostatic expansion valve, how would all that be different, Glenn?
Well, you'd have to correctly choose the valve to make sure you had the right power element with the right charge, and then you'd actually have to physically adjust the valve and observe what was happening with superheat to dial in superheat to where you need it.
So that's where this commissioning process thing is expedited with the arrangement you see here with an EEV and the controller package.
That is correct.
Now, there are some short videos available for your viewing pleasure on the Sporlan website and out on our YouTube channel. These videos include details on these Kelvin controllers that we're talking about as far as installation and initial setup and how to program them. The videos covering EEV troubleshooting techniques include use of a volt ohm meter and the step motor actuator known as an SMA12. These videos talk about all those things. If you're going to deal with our controls, our step motor valves, these videos are certainly worth your time and effort to take a look at them. We've already talked about standalone controllers. Here's an example of another kind of controller. These EEV controllers are classified as integrated controls or case controllers. Here's an example of Sporlan's S3C control. What does S3C mean, Glenn? I don't know. What does that mean?
Well,
it means it'll control 3 stepper valves in a case. Is that what that means?
No, Jim, unfortunately it does not. But what it does mean is it's all about safety and service and security. So it has all of those 3 things built in because we know anything electronic can be hacked. That's where the security comes in, and we want to make sure we're taking care of the proper safety for the food, for the other materials being cooled. And then we want to make it simple for the guy out in the field because there's nothing worse than having to struggle to try and understand how to program something or set it up right. So it's all about those 3 things: safety, service, and security.
Okay. All right. Well, that sounds pretty straightforward. And I'm told it can readily interface with the typical building EMS or BAS and can control many additional parameters as well. In fact, the case controller can not only drive the EEV, but it also has onboard relays to control the lights, defrost, fans, and even anti-sweat devices. These case controllers are typically in communication with that energy management system or the building automation system for data storage. And something neat here, I'm told, Glenn, it looks like the S3C itself has onboard storage for up to what? Is that right?
14 days of data.
14 days. Let me see if I do the math on that. Is that how many weeks is that?
That's 2 weeks, Jim.
Wow. That's pretty neat. With any of these controllers, choosing the right sensors is key. Sporlan offers a number of temperature sensor models. Here are just 2 examples. The 3K surface sensor, the 3K air sensor. We also have the 2K version as well. The Sporlan 3K sensor can be identified by its brass sensing tip. That's the case in this particular example. Both these sensors will work with the Kelvin 2 series controller. We've found that the 3K sensor versus the 2K to be pretty robust, and it's recommended over that. We also offer a 10K sensor as well. Now this 2K, 3K, 10K business all has to do with what? Glenn, is that?
It all has to do with the resistance of the sensor, Jim.
Yeah.
And that sensor, that's why the controller needs to know that so it can actually get the right temperature for the right resistance or
Gotcha.
reading that it's provided.
Yeah, I think George Ohm kind of got the short end of that because we don't refer to it as ohmage. We call it resistance, you know, everybody. Anyway, the appropriate pressure transducer should also be selected based on the pressure range seen in the system. As you can see here, we've got a few examples, 0 to 150 PSI gauge, 0 to 300, and 0 to 500. There are other models as well available for specific applications. These newer models can be easily identified by these fancy color-coded labels that are on them and the nice heavy-duty stainless steel construction.
That's exactly right.
Cool. Now, these electrically actuated, electronically controlled valves can be used to not only control superheat, but things like hot gas bypass, glycol. You know what? You're going to have to send me back to school so I can say glycol flow. Wow. In a secondary application, an evaporator pressure regulation as well. There are also specific standalone Kelvin 2 series controllers available to help complete the package. Now, Sporlan has recently launched a new standalone control option. Now, this is a fancy one. It's the Superheat control system, or the SCSSB step system control. It's an electronic superheat controller solution that is designed for refrigeration applications using the stepper type expansion valve, or EEV. It is designed to be mounted within the refrigerated space for ease of installation on existing equipment. The controller includes a coil outlet temperature sensor and connectors for the stepper valve, pressure sensors, and electrical power. Because this is an EEV, it needs electrical power. And guess what? I guess the B in the nomenclature here means it's Bluetooth compatible. Now, just so you know, we're just kind of focusing on the version that works with a step motor valve because this is an EEV presentation. We also have a pulse width version that's very similar to this. That, again, we will have some subsequent webinars that focus on these products. Now, here's how some of these other applications would appear in the vapor compression refrigeration system. If you take a look here, you'll see right here an SDR valve that could be used in replace of a traditional hot gas bypass valve and a hot gas bypass or discharge bypass application. We've been talking here about the EEV for superheat control, and we could also go down to the path of talking about evaporator pressure regulation via a CDS valve as opposed to an ORIT or a SORIT or a sport valve. In subsequent webinars, we'll discuss these different applications. Now, we're getting close to the time that we're going to start wrapping up here a little bit. Just to say, if you want to view an encore performance of this webinar, it'll be posted on Facebook, YouTube. It'll show up on Facebook first. Eventually, it'll be out there on YouTube for you to view as you like. You can see here, we've got the tech support phone number and email address, and you can follow us on all these different venues and stay connected with us. Sporlan.com has technical literature, training information, e-newsletters, product videos. Those are becoming very helpful. We also have our new virtual engineer sizing and selection tool, talk about new product releases. This is all good stuff. Now, if you have a question that's pertinent, I don't know if we've been passing over any questions, Glenn, that we need to address right now. We could address a few questions if it makes sense. We will go back and look at any questions that have been posed to us that we haven't handled. We'll do a Q&A blog that we're going to put online.
Yep. Jim, we do have a question or two I think that's appropriate for this venue.
Okay. Do I need to go back a slide or two?
I do not believe so, not for this one.
All right, go for it.
So the question is, on a power failure, does the valve stay at its last position or does it drive shut? Well, here's what I know about that subject, if you don't mind, Jim.
Go.
All right. So the valve itself, when it loses power, it is not going to move. It needs electricity to make that happen. Now, some controllers have an actual built-in battery so that they can actually shut that valve upon failure. So if that's the case and the controller has that, then yes, that valve will go shut because that's the way they're programmed. However, if they do not have that battery backup on there, then they cannot go shut. However, it seems like, if I remember right, many controllers will actually, on a re-engagement of power, reinitialize that valve so that it knows where it's at, so it can then start up and start functioning properly.
Yeah, that's a really good question. I guess in general, as you can see here in this diagram, like in the hot gas line and over here in the liquid line, we're actually depicting the use of solenoid valves to be used in general. There are some specific instances where there are neat controllers that have got that extra feature built into them like you're talking about. Mm-hmm. We got any more questions there, Glenn, that we ought to address?
At this time, it looks like most of these questions are either inappropriate for this venue because they talk a lot about controllers and how the controllers do their job.
Okay, so then...
And that's really a whole separate subject than the electric valve itself.
Well, then what I'm going to say is we will take each and every one of those questions, we'll craft an answer, and we're going to post it in a Q&A blog that we will post online. So just as a reminder, we're doing another webinar on May 21st, that's next week, regarding refrigerant retrofits. And then again, next month, we'll cover more on metering devices, you know, refrigerant distributors as opposed to aftermarket wholesalers. Mm-hmm. And unless you've got any other questions you want to deal with, I'm going to tell everyone thanks for joining us today.
Well, we did actually get another question, Jim.
Oh, gosh.
So
I jumped the gun. Yeah. Go.
So, you know, one of the questions is how long does it take for a valve to open or close? Well, we've got valves that are range from, 2.5 tons to, 400 tons. And each of those valves actually takes a little bit different amount of time to open and shut. Mostly because we want to make sure we're providing good control mechanisms. And this has to modulate most often around a very small range of control. So it is understandable that you may want to know how fast it operates because you want it to pull down fast or get to the right position in a hurry when you first start up. But it is valve dependent, so our valve and, whether it's an SERAA or, an SEHI, well, it might have a different amount of time for each one of those. So I could say a number, but it's only going to apply to one of them. So you really have to look at the literature that comes with those and what's in there to actually know that answer to that question.
Yeah, the other thing that comes into play with that is we have valves with different numbers of steps, right?
That is exactly correct.
And so if you got a valve that has almost 1,600 steps versus a valve that has almost 6,400 steps, there's going to be a time function there that's going to come into play, right?
Absolutely.
Absolutely. And traditionally, we're going to control these valves with so many steps per second based on the controller that they're using to tell them what to do.
Right. A lot of what makes a valve good is all about the algorithm and the programming inside the controller to make that valve go to its right spot.
So you get good resolution and good control features.
Exactly.
Do you have any other questions there, Glenn, that we ought to address while we got a little time?
Here's one. Can the valve modulate on temperature while maintaining a minimum superheat? Now, what you're actually saying is, can the valve modulate the case temperature is what it sounds like, while maintaining superheat? And the fact of the matter is no. This is a superheat controlling valve. That is all the valve is meant to do. To maintain temperature in the case, you have other controls inside the system, such as an evaporator pressure regulator or other things. The electric expansion valve is meant to control superheat and superheat only.
Good point. Here maybe this helps to reinforce that. When you're looking at this diagram, the inputs to this Kelvin controller in this example are pressure and actually there's two temperatures being inputted to this one.
Yep. Jim, that question came up also about why that second sensor's on there. And for a superheat control, that sensor is absolutely not necessary. That's actually sensing
good point.
The case temperature or the air temperature inside the case. So to control other features of the valve. We were just talking about a superheat control here. Sorry, we just did not get that taken out before we started this webinar.
Fair enough. Other questions?
What refrigerants are preloaded on the controllers?
Oh,
I can't
wow.
give you an exact number, but there's like 50,
Okay,
60,
that's a
70.
good, yeah, there's a bunch. In fact, that would be a good one for the blog.
Yes.
Or I will include, I'll include a link to get you to the correct information that'll describe that for you, because that's a complicated answer. And we're getting a signal back here from Billis, who's kind of telling me to stop talking. So I'm going to say, thank you for joining us. Remember that we got 2 webinars coming up, and this concludes our webinar on EEVs. And thank you for completing another Sporlan Chill Skills Tech Talk.